Okay, this is number 27.74. This is the light bulb emitting a certain amount of energy uniformly in all directions. So you have a light bulb. Emitting light in every direction. 360 degrees think of it as a sphere almost. And it says it's 100 watt bulb, which we know is the power, which is the energy per time. But it's only a certain percent. In my question, it's 2.5%, so I'll use that. So basically, 2.5% times 100 watts is equal to the energy per time. So 2.5 joules per second is what a watt is, equals the energy of all of these photons per second. So that's NHF per T. What we can do is solve for the number of photons per time by dividing the HF over here. And we'll get some answer. We'll get a number. That is not how much of that light hits your pupil, though. Your pupil you can think of as a very small sort of window in this larger sphere that all of the light is passing through. So this number that you just found is all of that light. So if you want to know how much reaches your pupil right here, you have to take the area of your pupil and divide by the area of that larger sphere, and that will tell you how much of this number, what percentage, I guess, if you want to think of it that way, of that number actually reaches your eye. So you're going to take that number and multiply it by that. So this is going to be pi r squared, where the r, in my case, was 4 millimeters in diameter, so you'd convert that to meters and also to a radius. And you're going to divide that by 4 pi r squared, which is, I think, the area of the sphere. You guys double check that. And then multiply that by n over t, and that will give you an answer where you plug in my case it was 1.3 meters away is where your pupil is. So that's this distance here. Okay, so you have this larger sphere that you're dividing out your area of your pupil. Good luck.